thumbs up that you hear me and see the board okay? All right, here we go. So we are finishing our day 3 notes. I'm sorry. We are finishing our day 3 notes on the trig identities, the properties of trig functions. So the next set of problems that we're working on, keep in mind that you want to rewrite as much as possible in terms of a reference angle. So if it's not in acute positive angle, you probably want to rewrite that in terms of a positive acute angle. And you'll see what I mean when we get there. Otherwise, we're really looking for, ways to bring in an identity to rewrite one trig function in terms of another. So maybe we can get things to cancel and things like that. So look at the first example. It says use the properties of trigonometric functions or identities to find the exact value. So again, you shouldn't be using a calculator because they want the exact value. And it says do not use a calculator. Here we go. Sine 80 degrees times the cosecant of 80 degrees. Now, 80 degrees is not one of our special angles that I would expect you to know the sign of off the top of your head. In the future, if I asked you guys what's the sine of 80 degrees, you'd have to use a calculator for that to get me that ratio. This is not something that would live inside of a special right triangle. But we're just trying to basically simplify this expression. So guys, if you notice, the cosecant of 80 degrees, that's the reciprocal of sine. So you can rewrite this as the sine of 80 degrees, which is already written in terms of a reference angle, a positive acute angle, times cosecant. Guys, he's 1 over the sine. So we can rewrite that as 1 over the sine of 80 degrees. And now a sine 80 and a sine 80 will cancel. And really the value of this expression is just 1. So that's what you're basically trying to do. You're trying to get things to kind of cancel or use some type of identity. All right, look at the next one. I wrote our Pythagorean identities over here just to kind of have them handy because I won't have my notes to go back and forth through. So in part B, it says we have secant squared of 18 degrees minus the tangent squared of 18 degrees. Notice they're both talking about the same angle measure. So if you're going to use an identity, this one can't be 18 degrees and this one be 19 degrees. It has to be of the same angle. Well, guys, come over here because those are squared trig functions. Maybe there's some type of identity. And if you look at it, if you take, which one is it? Right here. If we were to, I think I wrote this on the first day's notes. If you were to minus tangent squared over, you would have secant squared theta minus tangent squared theta equals 1. Well, guys, this is literally secant squared theta minus tangent squared of the exact same angle theta. That's an identity. So secant squared theta minus tangent squared theta, no matter what the angle is, it's 1. The answer to this problem is 1. And that's literally just from an identity. All right? Let's go to the next one. And again, we're going to use identities even in the next chapter when we're working with trig. These are kind of like simple ways to sub things in and out. In the future, when we start really working with some trigonometric expressions, there's some heavy duty subbing in and out of identities. These are kind of keeping it pretty basic right now. All right, look here. It says the cotangent of 20 degrees minus the cosine of 20 divided by the sine of 20. Well, the good news is they're all already in terms of this positive acute angle. They're all the same angle, so I could hopefully apply an identity. 2 ways you could think about this. Guys, cotangent by definition is who divided by who? Cosine divided by sine. So literally it's the exact same expression. Or you could say cosine divided by sine is cotangent. So I could literally rewrite this as the cotangent of 20 degrees minus the cotangent of 20 degrees. So no matter what that angle is, this problem is going to equal 0. They're going to cancel out. So whether you chose to rewrite this in terms of cosine over sine, then you would have the exact same fraction minus the exact same fraction. It all becomes 0. All right, is everybody okay so far? All right, so now we're going to have to do some finagling in the next few examples. So look at this one in part D. This one says the cosine of 400 degrees times the secant of 40 degrees. So I hope you're already thinking, oh, cosine, secant, they're reciprocals. Yes, yes. The problem is right now, they're not talking about the same angle. One of them is talking about 400 degrees, the other one is talking about a 40-degree angle. So what we want to do with the one that's not the positive acute angle, we want to rewrite this in terms of his reference angle. So guys, kind of take this off to the side. Where does 400 degrees land? Well, if I go all the way around, there's positive 360 degrees. So to get to 400, I have to go 40 more degrees. Does everybody agree with that? So really, 400 degrees, guys, it actually lands in the exact same spot as, what is this reference angle right here? The angle between your angle and the x-axis? 40 degrees. It's 40 degrees past 360. So 400 degrees, it lands in the exact same spot as a 40-degree angle. So that ordered pair that references the cosine and sine of 400 degrees, guys, it's that ordered pair that we would use to build a right triangle, and it's really the reference angle 40 that would fit in, and it's that x and that y and that radius that we would use to build all of our ratios. So in reality, the cosine of 400 degrees is the exact same thing as the cosine of a 40-degree angle that landed in quadrant 1. So we can rewrite cosine 400 as the cosine of 40 degrees, but you got to bring around the correct sign. Would the cosine of an angle in quadrant 1 be positive or negative? It would be positive. Not unpopular today. It would be positive, so we can say that this would be the positive ratio of cosine 40. So I can literally rewrite that as cosine 40 degrees. And it's positive because the cosine of any angle in quadrant 1 is positive. All right, and then I can times it with secant 40 degrees. Guys, that's 1 over cosine. So that would be 1 over the cosine of 40 degrees. And then there you have it. Cosine 40 cancel. The value of this expression is just 1. Okay? Is everybody okay with that? All right, let's look over here. Same thing. The sine of negative pi over 12 times the cosecant of 25 pi over 12. So I hope we recognize this is sine and cosecant. They are reciprocals. There's definitely going to be an identity. But right now, this is not written in terms of a positive acute angle, and either is that. So we want to rewrite these angles. Well, guys, we can use our sine, S-I-G-N, our sine, positive or negative identity. If it said the sine of the opposite of theta, we saw yesterday, we can pull that negative out in front. And that would be the opposite of the sine of pi over 12's ratio. So we can rewrite this as sine, the opposite of sine pi over 12. Okay, times the cosecant of 25 pi over 12. Guys, we got to get that in terms of a reference angle. That's way too big. So you're working with pi's over 12, right? So remember, pi gets you halfway around the circle, and 2 pi gets you all the way around the circle. So in the world of pi's over 12, it would take 12 of them to get you halfway around. That would make pi. And it would take 24 of them to get you all the way around. So 25 pi's over 12 would be 12. 12 more is 24. I'd have to go 1 more pi over 12 to make 25. So the reference angle is right here, and that's the one that we would have inside of a right triangle. So really, the cosecant of 25 pi's over 12 is the exact same thing as taking the cosecant of 1 pi over 12, but you landed in quadrant 1. And in quadrant 1, the ratios are always positive. So we would say the positive ratio of cosecant pi over 12. Now you can rewrite cosecant. You can even write this as 1 over cosecant, whatever you want to do. I'm going to leave it as the opposite of sine pi over 12 times 1 over the sine of pi over 12. And now they're going to cancel, and you're just left with negative times 1, which is negative 1. So you always want to rewrite in terms of the reference angle if it's not a positive acute angle. All right, let's look at the last one. I got to make room for this one. It's a little cramped. All right, so we have the sine of negative 20 degrees, right? And again, you can even, if you don't even think of the identity, guys, negative 20 degrees is right there. So the reference angle is 20, but what would the sine be, positive or negative, of an angle who landed in quadrant 4 when you take the sine of it? All students take calculus. Only the cosine of an angle is positive in quadrant 4, which means the sine of an angle in quadrant 4 gets you a negative ratio. So it's going to be whatever the sine of 20 degrees is, it's that ratio, but it's negative because you landed in quadrant 4, which is the exact same thing that this identity tells us to do. Take the negative out, and it'll be equal to the opposite of the sine of 20 degrees. So whether you think of it as rewriting in terms of a reference angle or whether you think of this as using the identity, it all works. All right, over cosine 380. That's way too big of an angle. Let's rewrite cosine 380 in terms of a reference angle. So where's 380 degrees? Well, guys, here's 360. I got to go 20 more degrees to get to 380. So really, the cosine of 380 degrees is exactly the same as taking the cosine of 20 degrees when you land in quadrant 1. And what is the cosine of an angle in quadrant 1, positive or negative? It's definitely a positive ratio. So it'll be the positive ratio of whatever the cosine of 20 degrees is. And then plus tangent 200, guys. We got to rewrite 200 degrees in terms of a reference angle. Where's 200 degrees? Well, there's 180 degrees. So I got to go 20 more degrees to get to 200. So really, what's happening here, your reference angle is 20 degrees. So the tangent of 200 is the same as taking the tangent of 20 degrees, but you're in quadrant 3. So would that ratio be positive or negative? All students take. The tangent of any angle in quadrant 3 is a positive ratio. So it's the positive ratio of tangent 20 degrees. So it would just be plus tangent 20 degrees. And now you have two options. I can rewrite tangent in terms of sine and cosine, sine 20 over cosine 20, or you can rewrite sine over cosine as tangent. So really, this is the opposite of tangent 20 degrees plus the tangent of 20 degrees. What do they add up to? Nothing. They cancel, so it's 0. All right? So again, a lot of these identities are either very, very obvious, you can rewrite in terms of an identity, or it's all about rewriting in terms of a reference angle. And guys, if you notice, the reference angle always seems to be the other angle that you need. Otherwise, they wouldn't be asking you these questions because you wouldn't have anything canceling. Okay? Are you guys okay with these examples? Yes? Everybody at home, thumbs up, we're okay? All right, let's go to the next set. Okay, this one says, if the sine of angle theta is equal to 0.3, right? So we don't know what angle we just took the sine of, but we know the ratio is 0.3. Find the value of sine theta plus the sine of theta plus 2 pi radians plus the sine of theta plus 4 pi radians. Now, guys, this has a little bit to do with the fact that these functions are periodic. After so many angles go in, the outputs just start to repeat themselves. I mean, think about it. You're on a circle. We just saw 20 degrees, and then what was it? 380 degrees. They all have the same cosine and sine because they land in the same spot. So all those outputs start to repeat. So it's got to do with the period of each trig function, the amount of time it takes to repeat, but we haven't really gotten into the periods yet, but you'll see. So guys, picture this. The sine of an angle equals a positive ratio. That means that angle had to be in quadrant 1 or quadrant 2. Let's let it be in quadrant 1. So give yourself an angle that landed in quadrant 1. So when we come over here, they're asking us to find the value of this expression. Who did they already tell us the sine of angle theta is equal to? 0.3. So that's going to be 0.3 plus. Now we're trying to figure out what's the sine of theta plus 2 pi radians. Well, guys, don't you agree? 2 pi radians is one complete rotation. It's one complete revolution. So if I'm already at angle theta, if I rotate around a complete revolution, a complete 2 pi radians from that angle, aren't I landing in the exact same spot? I am. I did one complete rotation, so I'm landing in the same spot. So the sine of theta plus 2 pi lands in the exact same spot. It's going to have the same ratio. So that's 0.3. Plus, let's say you take theta plus 4 pi. Well, guys, you've already been at theta and added 2 pi. Let's add another 2 pi, which would be another complete rotation, which would be 4 pi's away. You're still landing in the exact same spot as theta. So the sine of that angle is going to be the exact same ratio as the sine of angle theta. So that is 0.3. Because what happens with the sine function is every 2 pi radians, the output repeats. That's the actual period of the sine function. Every 2 pi radians, you get the exact same ratio because it makes one complete rotation and it puts you back in the exact same starting spot. So then you're really just getting 0.9. And you're done. Okay? All right, now tangent's a little bit different. They're telling you if tangent theta is equal to 4. So again, the tangent ratio would be positive for an angle in quadrant 1 or quadrant 3. Let's make this easy. Let's let it be in quadrant 1. So give yourself an angle that landed in quadrant 1. Now they want us to find the value of tangent theta plus the tangent of theta plus pi. Now they're not asking you to do a complete rotation. Pi radians is half of a rotation. So guys, if you think about this, if I went pi radians from there, it's half of a circle. It's half of a rotation. So it's putting you at the exact same reference angle, but now you're in quadrant 3. Well, guys, what is the tangent of an angle in quadrant 3? All students take. It's still that same positive ratio as quadrant 1. So if the tangent of angle theta is 4, the tangent of angle theta plus pi, it puts you in another quadrant where the tangent is positive again, and it's going to be of the exact same reference angle. It's still 4. So what happens with the tangent function, guys, is his outputs repeat themselves faster than sine. Sine, you got to do a complete rotation to get back to where you started, and those outputs start to repeat. When we start looking at the tangent graph, you'll notice with tangent, it doesn't take a complete rotation to the outputs start to repeat. They actually repeat every half of a rotation. So half of a rotation pi radians, I get the same answer. Now theta plus 2 pi, well, I've already rotated 1 pi. If I go another pi, that's 2 pi radians. Now I'm back to the exact same angle I started at. That also has a ratio of 4. So that's going to be plus 4. So 4 plus 4 plus 4, we get 12. Is everybody okay? So again, when we start looking at the graphs, you're going to notice that the sine function, you have to do a complete rotation, 2 pi radians to repeat. But the tangent repeats faster. Every half of a rotation, every pi radians, his outputs start to repeat. All right, and then the last one, look at this one. It says if f of theta equals sine theta and f of a equals 1/4, find the exact value of these. Well, guys, first of all, when we plug angle A into this function, f of a, that means the sine of angle A is equal to 1/4. That's the information they've given us. Now they're telling you if you plug the opposite of A in. So now you're talking about the sine of the opposite of A. Well, guys, we've already seen the sine of the opposite of A, that's going to be the opposite of sine A. And what did we already say sine A is equal to? 1/4, but it'll be the opposite. So this will be the opposite of 1/4. That's just a straight up sine identity, S-I-G-N sine identity. Okay? All right, and then you guys do this one because you guys should be able to do this one now. If f of a is equal to 1/4, the sine of angle A is equal to 1/4, then what's f of a plus 2 pi and a plus 4 pi? right? It's all that rotating again. F of A was 1/4, so A plus 2 pi puts you at the exact same angle. 4 pi puts you at the exact same angle, so we're just adding 1/4 3 times, and we should get 3/4 as our final answer. Is everybody okay? Awesome. All right, so I actually added this last example, guys, at home. I apologize. I didn't realize it was in my notes, so I added this last example to show you. It must be in the homework. That must be why I wrote it down. Okay, and guys, remember, I know that I keep saying, we've redefined the trigonometric functions to use a point, an x-coordinate, a y-coordinate, and a radius, and this is why we can take the sines and cosines and tangents of all of these huge angles that wouldn't fit inside of a right triangle, because we've redefined these ratios, right? But at the end of the day, it's still trig. If you can get a right triangle to look at with an O, an A, and an H, have at it. Please don't deprive yourself of that right triangle, because trig to me is so much more understandable when you're looking at a right triangle. So this one says, given the sine of angle theta is equal to negative 2/3. Well, guys, right then and there, they're giving you a clue. If you take the sine of an angle and it has a negative ratio, you know that's not a quadrant 1 or a quadrant 2 angle. It's got to be a quadrant 3 or a quadrant 4, because that's where the sine of an angle would have a negative ratio, a negative y coordinate. It's got to be quadrant 3 or quadrant 4. But then they go on to give you an even clue. They're telling you that angle theta is in between pi and 3 pi over 2. Guys, on a coordinate plane, here's pi, right? It's your second 90-degree angle. It's 2 pi's over 2. And then here's your third 90-degree angle, your 3 pi over 2. They're even telling you that theta is in quadrant 3, okay? Find the 5 other trigonometric functions. Guys, let's use what we got. We clearly have an angle that is landing in quadrant 3. Now let's build a right triangle. We have a point that it's going to intersect the circle at. Let's build a right triangle using that reference angle. You always build your triangle to the x-axis so you can use the reference angle. So here's my reference angle. I don't even have to know who it is. But they're telling you we have an angle. We now have basically a y-coordinate or an O. We have an x-coordinate or an A. And we have a hypotenuse or a radius, however you want to think of it. Guys, they told you the sine of this angle is negative 2/3. So that's a y over an r, according to the new definition of sine. Or go old school. It is an O over an H at the end of the day. So it's an O, which would be the opposite side, which would be 2. Over an H, a hypotenuse of 3. But hold the phone. The ratio is negative. Who gets that negative sign? The 2, which represents the y-coordinate, or the 3, which represents the radius, which is never supposed to be negative? The 2. So make sure you give the correct signs to these numbers. Now, if you could find the x-coordinate or the A, if you will, there's no trig ratio you can't find. So a little Pythagorean theorem. A squared plus b squared equals c squared. So 9, take away 4 is 5. Square rooted, this has to be a root 5. But we are in quadrant 3. It is representing an x-coordinate. Would this value be positive or negative? Negative. So it's on you to know to make that negative. Otherwise, you will not have the correct sign of all the other trig ratios. Guys, let's do it. Let's find we got what? They gave us sine. Let's do his reciprocal, get that over with. Cosecant is the reciprocal of negative 2/3, negative 3/2. All right, let's go cosine. The cosine of angle theta, it's x over r, or guys, it's a over h. It's negative root 5 over 3. All right, let's do his reciprocal. Let's get secant. The secant, I can either take the reciprocal of that, or I can come over and do h over a, or r over x. It doesn't matter. It's negative 3 over root 5. Clean that up. Little rationalization here. And I'm going to get negative 3 root 5 over 5. All right, we got tangent and cotangent left. Tangent You can either think of it as a y coordinate over an x coordinate, or it's an O over an A, however you like it. So it's -2 over -√5, which means it'll reduce to a positive, which it should, because the tangent of an angle in quadrant 3 should definitely be positive. All students take. All right, and we'll clean it up. And you should get 2√5 over 5. And then the last one we have left is cotangent. So you can either reciprocate this, but I would reciprocate it before you rationalized it, or come back over here and say that it's A over O. It's X over Y. So it's -√5 over -2, which is +√5 over 2. And you're done. So again, if they're going to gift you one of your ratios, a quadrant that the angle is in, guys, you got to go to that quadrant. You got to build yourself a right triangle. Just make sure you label the signs correctly with your plus or minuses. The radius is always positive, and there's no trig ratio you should not be able to find. Is everybody okay? Awesome. At home, are you guys okay? Okay, thank you. So listen, that's it for section 3. I didn't make a new homework for tonight. It's just the homework that I posted yesterday. It's due Sunday night, and I'm giving you tomorrow in class to work on the homework. All right? So again, I'm not going to make you come to a Google Meet tomorrow. If you need me, just reach out to me. I'd be more than happy to help anybody who needs it. But you can just work on your homework tomorrow, and I will see you guys on Monday. All right? All right, let me double check the attendance at home, and then you guys will be good to go.